to another episode of the Open Source Cafe, and I'm really excited for this one. We have Avinash joining from Metabob. We're going to talk about AI, but more specifically, we're going to talk about AI in code reviews. Before we get started, Avinash, would you like to give yourself a quick intro?
Yeah, so my name's Avinash Gopal. I'm the CTO at Metabob. So essentially, I'm in charge of developing all the tech and also working with a bunch of great researchers from all over the world to develop new techniques and new methods to do AI code review. And really excited to be here.
Amazing. We're looking forward to learning a lot from you. Can you maybe share a little bit about your journey? Like, why did you think that there was a need to have an AI code review tool? I know humans are not very good at always giving constructive feedback, which is what I have observed uh, when working in various projects. But is this like a first startup, or what did you do before this, and how did you come across the idea for starting Metabob? And maybe if you can tell a bit about Metabob as well for folks who might not be familiar.
Yeah, so Metabob is our AI code review tool. Essentially, we started this project well before the recent advancements in generative AI. We began in like late 2018, 2019, and it started as a research project that Masi was assisting a couple of universities, so Princeton as well as this NEC Labs group. And from there, me and Masi had met through the open source community. I'd worked on a couple of different projects with him, and my background is generally in research engineering, but I was doing a lot of machine learning and computer vision stuff as part of that research engineer role. So I just sort of blended very nicely into projects that I was doing in the open source community with Masi, and then he brought me on. Masi is our CEO, my co-founder. So we essentially were able to take advantage of a lot of good research opportunities to learn about how to do like code understanding, and we were able to try and apply that to this particular task. At the time, we wanted to do code generation, but I mean, the thing that we wanted to tackle first was fixing code or providing like meaningful explanations and fixes for existing pieces of code. So we spent a lot of time understanding like how code changes are made and what's important about them, and really tried to distill that down to its core principles.
And how would you say that it's like your AI powered code review system differentiates itself from like traditional code review processes? I think it's pretty like I was using it for Python, and it was also from sharing, like okay, this the code logic is not good, and to more severe issues like okay, this is a security vulnerability, and it also mentioned that you're not having good naming conventions. So how do you think it differentiates from like a traditional code review process? Like what is it that the AI code review tool is doing differently? Or does it have to do something differently?
I mean, the ideal code review process, at least for an AI code review, would be somebody who's very senior and understands what you're trying to do and can give you direct, to-the-minute feedback on exactly any issues that you may have inadvertently created or any oversights you may have made, like a real peer program, somebody to assist you all the way through and give you like good feedback every single time. So compared to the traditional code review process, which is manual, done by either a senior engineer or the maintainer of an open source repo, or like just a volunteer, it's somebody who understands the code base deeply and understands how things are set to work together. And when you violate those conventions, they'll let you know. And that's kind of what we've tried to train Metabot to be like. Our model, the way that we built it, is fundamentally based in the code context. So we're able to understand structurally how all the pieces of code work together. And what we're doing is we're basically identifying uh, or predicting like where changes would have needed to be made in like open source projects or in like company projects or your own code history, and be able to let you know ahead of time that you'll probably need to change this in the future, and here's why.
Right. So my another question follow up on this is like, do you think it's like a replacement for human code reviews or like an additional enhancement?
Maybe one day, but at the time being, I think the main value proposition that we're able to provide here is we can weed out some of the more rudimentary or common issues, as well as some of the more specific but like rare issues that stem deep to the code base. And essentially, we're able to decrease the amount of bad code that these senior code reviewers or these code maintainers are seeing, and ideally make their day a lot better because then they only have to focus on a couple of very significant fixes and not a whole lot of very minor changes that they request.
Right. Um, yeah, thanks for sharing. And that, when I was using it, I felt like this is really good. Before, let's say you make a PR, you can run the Metabob, like you can analyze your code files, make some changes, then you can make a PR, then a human can review or whatever. Maybe someday, like you said. So about these code review practices, what are some of these practices that that your solution addresses? Like, are there any specific challenges, or like how is it designed in terms of giving back the code review?
Yeah.
What does it
So
focus
in
on?
oh yeah. So in comparison to other like static linting tools or other things that you would run as part of the IDE to like scan your code for various problems, we're able to detect or learn to detect problems that would occur at runtime. So things like race conditions or memory leaks or like mismanaged internal states or other things that would only really appear after you reach a certain scale or you get a certain number of inputs or as you're building up your application and it starts to be used, you start encountering these problems. And because we're looking through our training data essentially to identify these sorts of problems that would only be possible to detect at runtime, we're able to preemptively flag those. So that's the main thing that we're focused on trying to find. But we also find more common things as well. Things like the more basic syntax errors or code style security problems as well. We run the whole suite of options.
Nice. Well, thanks for sharing, Avinash. Since you're this, the CTO, can you maybe talk a little bit about the underlying tech stack for the tool, if you're okay with sharing that? Like, how did you make it? I'd love to hear your story with that. Yeah.
Yeah, so we are trying to keep it relatively simple. Obviously, most of the machine learning pipeline stuff that we developed in order to train the models and bring them to deployment was initially set up in Python, but we actually use Dask as well as a couple of other tools, part of our Kubernetes stack, to go and automate a lot of the data collection, training, and preprocessing uh, tooling so that we're able to bring models efficiently to the users. And in addition to that, we also built essentially uh, a fairly basic like worker pubsub based Kubernetes backend to support doing inferencing across multiple different uh, like platforms with multiple different users by funding all of those essentially through like a Redis stack to go organize everything. And then yeah, and then in terms of the front end for the VS Code extension, obviously that's in TypeScript, and for the back end, just to keep things simple, we did it in Python as well for the time being. But some of the processing that we do is written in Go.
Yes, thanks for sharing, Avinash. And we have Masi joining us as well. Hi, Masi, how's it going?
Hello, Kunal. Thank you for having us. Doing great. How about yourself?
Yeah, doing all right. I was having a good conversation with Avinash, and now Masi has joined the podcast. Masi, would you like to give yourself a quick intro?
Yeah, sure. Yeah, my name is Masi. I'm the CEO of Metabob. I've been working on this project for the past 4 years along with Avi and our great team. My background is kind of in a mix between engineering and business. I consider myself probably a serial entrepreneur. Started my first company at the age of 2019 back in Italy, where I'm originally from, and that's what brought me to California. After selling that company, I worked in the VC space for a couple of years, and now I'm full time on Metabob, trying to make the dream happen, I guess.
Amazing. Yeah, I like California. Been there multiple times now. This last year. But yeah, very cool. So we were just talking about Metabob and specific challenges you're solving. Another question I have, and I'd like both of you can weigh in. Like when you're determining the quality and readability of the code through your AI system, what are some of the factors that you consider in order to do that?
I mean, at a very fundamental level, the difference between us and I guess the more conventional AI techniques, so things like large language models, uh, the main difference between us and those sorts of techniques is that we are looking at uh, the underlying structure of the code, and we're using a graph neural network to understand how those parts fit together, as well as learn essentially uh, exactly what is most relevant within the overall structure to be able to identify these sorts of patterns. And essentially, what we're doing is we're translating the code into something that's a generic program format that sort of encodes all of the main operations and what their intention or what the reasoning behind those operations by pulling in additional context.
Well, I adding on that, I guess. Well, I've already provided the explanation in general, but yeah, I mean the goal specifically for our tool, and I mean I don't know if I'm answering the questions, but it's really like focusing, adding like an additional layer on context understanding compared to specifically Copilot or other AI focused tool to really be able to enable developers to understand the cause behind logical or complex issues within the code. That's really what drove us as developer ourselves to started the company to be able to like yeah, just enable people to get that understanding.
Yeah, thanks for sharing, Avinash and Masi. My another question is like, since it's an AI tool, so as an AI code review system, like you have to remain up to date, with all the latest programming languages and all the best practices that you recommend. So how do you ensure that your tool is staying up to date with all the latest, like trends and best practices? Yeah.
Well, like most AI tools, I guess you could say, we employ two methods for that. One, we're constantly getting and fetching new data and going through it and trying to parse out exactly what's changed from the previous data, if anything, and further refining our results using that. And then secondarily, there's the ever-present user feedback, or essentially whether or not they're accepting the changes that we're suggesting, or they're like acknowledging that the problem exists by making changes in the areas that we flagged. And we do this like through the service essentially. So as people are using the tool, we're able to refine the results based off of whether or not people are responding positively to them or
Uh, Thanks for sharing, Avinash. Masi, do you want to go next?
Yeah, well, again, I think like in that case, Avi already pretty much answer right from like our uh, like view standpoint. Like on top of that, I mean, again, adding just some additional context, like what we always do is, which I think is very important for every entrepreneur, and every time you develop any type of dev tool, is constantly, checking in with your user, look at user feedback, trying to communicate, stay in touch with your community of people. I'm sure you know, just like as well as us, as you have a huge community as well, and just making sure that your product is up to date. Right now, for instance, for us, we mainly cover Python, but we are starting to add additional cover for Java, JavaScript, TypeScript, and in the near future, we plan to also add C and C++. And one of the reasons why we do that is also looking at what user wants, and trying to see, just hear from the community, right? uh, so yeah, well, that's
Nice. Thanks for sharing, both of you. My another, like, something that I've noticed is, so like when I was new to open source, was contributing to this Kubernetes Java client project, and I made a PR. It was like really big, like the number of file changes and everything. So it took like really long for them to review it, and they were like, what would help us if you can break it down, you know, in individual PRs. So it was like a chaos. It was like so many lines of chat. It was 10,000 or whatever. But that made it like a little bit like put a little time on the maintainers to review my code. And the feedback they gave me was, if you can break it down, that'd be helpful. So how does your tool work with like how does your system handle the complex code bases and large scale projects during the review process?
Yeah. So largely, if there's a lot of file changes, that could be for a number of different reasons. But if you're following like the best practices when it comes to making a PR, trying to keep it very focused on a single underlying change or a single feature that you're trying to adjust, then essentially most of the code changes from across the code base are going to be updates of the internal APIs to match any like function signature changes that you may have made, or any algorithmic adjustments that may be breaking, right? So we interpret all code bases in generally the same way, and it's largely scale invariant. So we're essentially building this map of how the code is structured, and we're tracking that through time, essentially. So as different parts of the code base change in different locations, we're able to understand essentially that those different changes need to be made because you've made a change in a certain location. And we're actually able to predict that as well. So in some cases, if there are multiple changes that need to be made in multiple different files, when you go to those files in VS Code, we'll already have a response or detection and waiting for you that is essentially the reciprocal the change that you may have made in a different file. So because we're building the context like this, we're able to pull together all of the relevant use cases about when things are being called and when things are being defined and mapping accordingly.
Nice. Thanks for sharing, Avinash. Yeah, Masi, go ahead.
yeah. Well, well, again, I think Javi always provide a pretty straightforward explanations to that. So I guess, like, again, my point of view is always related to why we decided to do that, or what we had on top. And to your point, really, like, larger code bases or more complex projects is kind of like where you can really see the value propositions that we offer the most. As obviously, if you compare us to other tool and simpler like projects, then it will be harder. But due to the fact that we don't really have any token limitations, unlike ChatGPT or Copilot, and that's the main value of our technique. And there's the fact that our technique is able to understand different components within logical components within the code and their semantic markers. That's one of the core advantage of the graph neural network technique. And that's why we decided to go with that specific model when we started this project.
Nice. And before you joined, Masi, I spoke about the human part of the human element as well for code reviews, like how you balance the AI and the human review codes part. Right. Since we're talking about AI tools, I have one more question. So how do you address the concerns related to false positive or false negatives in your code review system? I know Avinash, you did a little smile there, so maybe you can go first.
I mean, it's a question that we always get, and also it's going to be a perennial issue with AI in general because it's fundamentally a fuzzier way of matching things, right? Because it's it's based off of a underlying architecture that essentially is predicting whether or not something is or is not going to be relevant, and there's various confidence intervals that it generates for each particular suggestion or each particular thing it's creating. Uh, so the way that our model works essentially in production is that we try and optimize the types of results that we show to only be things that we're strongly confident exist within the code base. And the way that we do this is essentially we're rating the the sequential confidence and setting a threshold on when we are displaying detections and when we're not displaying detections. And this is something that we can do relatively easily because we are fundamentally doing this classification test to detect certain types of problems. So we can determine that for these types of problems, we want to be this confident that we're making a good detection, or for these other types of problems that we are more lenient and willing to let them be detected just to see whether or not they're going to be relevant. So we set this on a case-by-case basis, essentially. So as users, they are essentially getting a curated list of things that we're relatively certain contain a problem.
Well, yet again, I guess like in this case, I don't even need to go next. Yeah, that's
Yeah, I have one. Yeah, so thanks for sharing, Avinash. I agree. It's like an AI, conversation you need to have when you're working with AI tools. But maybe one from a CS, can you maybe share any success stories or case studies that highlight the impact of your AI platform on code quality or like any developer productivity?
yeah, sure. So right now, what's our model? We have about, I would say, close to 150 unique categories, each covering about hundreds of different bugs for Python alone, which is by far still the programming languages that we have the best coverage with. Like, despite as Avi was referring to, our model percent is language agnostic. We've been mainly focusing on Python as most of our user base are Python developers. Some of the most popular use cases that we've seen from our user side, they range from all type of like race conditions. Handle edge cases is another big one, or internal API mismatches. When it comes to if the use developers, are using libraries like NumPy or Pandas, Skykid, so all type of data type errors related to those library, performance issue due to use of these modules, or platform specific problem. Uh, Probably next will be memory leaks or concurrency issues, deadlock problems. So those are just some. We always discover on our end as well on a daily basis some additional case study and use cases that we've seen from the user standpoint that have been pretty valuable. But the one I mentioned are probably um, the most common that we've seen that our tool is quite effective in identifying. I don't know, Fabi, if you have any additional one that comes to mind to you.
No, I think you covered most of the main categories. I mean, there's other ones that are more niche, like audio problems or like interfacing with different drivers or certain C libraries. But I mean, those only come up in specific sorts of applications. But in general, those are some of the most common problems that we have.
Cool. Thanks for sharing, both of you. So another nice question that a good question I had. But when we're talking about AI, you often talk about data privacy and security when you're working with code bases. The whole co-pilot thing, there was a big conversation around that. So maybe you can share a little bit more about what measures are in place to maintain this transparency and explainability of your AI algorithms during the code review processes, and yeah.
Yeah, so we're pretty transparent in terms of what we do with the data that we need to use in order to produce the inferences. Essentially, we do need to do it on the cloud because obviously we're running an AI model and it's not something that can be done locally yet. So it's something that requires certain types of resources. So to that end, we do need to store some artifacts from the code base, but we only store them in volatile memory only for an hour until the end of the session, and then at that point we delete it. Uh, what we are actually using to train the model is this intermediary representation, which is basically uh, a composite of your code base with a lot of the specific markers within there abstracted away to something that's not reversible back into the original code. And we are using this representation because it's generic. So it's language agnostic for us to train this representation versus like an individual type of code. And because of that, we can expand the number of languages that we support as well as do cross-training across different languages. But because of that, we're not actually using any specific elements from anyone's code, and it's not going to show up in any of the responses that we provide either, because they're simply not included in the data.
Yeah, and to add on that, like we're very committed to transparency. I think when you deal with user data, uh, especially when it comes to code, you want to. I think other tools in the past have mistakenly like weren't transparent enough. For us, is key to be able to again be transparent. We tell our data policy. You can find us on our VS Code extension overview page, as well as on GitHub. As Avi was saying, we delete all data from our problem detection model 1 hour after the users made their last API call. It's important to consider as well that we integrate or we enable developers to use third-party LLMs to generate the descriptions and recommendations to perform fixes. So we have to pass data to this model, and really we cannot control the way the data is used by the companies also in these LLMs. So it's always important for individuals and developers to know, especially if they select when setting Metabob to use third-party LLMs to generate those recommendations, like then we don't have any control, obviously, of what they do with the data.
Right, because that's a question that I get quite a lot whenever I introduce an AI tool, and it's nice to see the transparency and the stuff you do for the community. Thanks a lot for answering all my questions patiently. I have two more questions left. So my another question is like, what kind of integrations and collaborations do you have with any popular development tools or IDEs? I know there's VS Code. Is there anything other things in plans? I love JetBrains, by the way. So if you can
Yeah.
do something with that.
Well, it's good that you brought that up because we're planning to support JetBrains IDEs in the next couple of months, most likely by Q3 or Q4 in terms of our overall roadmap. So we're trying to extend support to the more common and the more popular IDs that are out there so that everybody can use it as well as use it in an environment that suits them. It's just something that we are also looking to possibly develop as part of like an open source language server type setup. So we'll be releasing some additional bits into our public repos in the next few weeks as well to help support that.
Yeah, so as Avi is saying, definitely next on the roadmap is adding JetBrain IDs. Obviously, PyCharm is a big one there, and just adding also like coverage support. So right now, again, our focus has been Python. However, we are releasing in the next couple of weeks the full support for Java, and then it will be JavaScript, TypeScript, and next, I believe it will be C and C++. And again, we always work with our team customers user to implement more languages. And by the end of the year, we want to definitely have like over, I would say, 7, 8 languages where we have full support through our AI within our free tool on IDs, on the IDE side, and as well as on the CI/CD. So you can also find us on GitHub, Bitbucket, and GitLab. So those, I would say, are the two main area that we're looking in terms of our roadmap to implement. So language support and IDE integrations.
Awesome. Thanks for sharing, Asi and Avinash. My last question to you is, how do you envision like the future of code reviews with all these nice tools coming out?
Yeah, well, if on my end, I think definitely what we've seen in the past 6 to 8 months, the environment is changing pretty fast, right? More and more people are using copilots and generative AI to write code, and those are extremely helpful when it comes to write code faster, and that is gonna keep improving. Uh, and I think it's important for developers and companies to adapt to that as well. Um, in our opinion, definitely what we want to be is like help developers first who use this copilot to be able to identifying and find problems that generative AI creates. So if you're familiar, if you use copilot to write code, you'll see like specifically when you write longer code, in many cases, actually, that does generate logical issues as well as security vulnerabilities. And our tool, due to the fact that we do train as well on the open source side, but we specifically look at code changes and verified code improvements, we're able to identify quite effectively problems generated by AI, but also obviously by humans. And um, our technique will enable us to add an additional layer of content and understanding. So we want to be used also along with Copilot. If you write code with it or not, still like our technique enable you or enable um, developers to add again an additional layer of context understanding of the code and be able to really find the type of problems that current rule-based tools as well as other generative AI hardly are able to find. So, in our opinion, definitely there is going to be a lot of opportunities for dev tools to enter in the space, and especially if they integrate with generative AI or specifically, obviously, Copilot and ChatGPT are the big ones. For us, what we see our value specifically is to again add a layer of context understanding to Copilot to provide better recommendations to the issues we detect, better refactoring recommendations, as well as just more context understanding of the code to facilitate, the token limitation, which seems to be one of the biggest challenge for ChatGPT and Copilot at the moment.
Yeah, and just to add on to that a little bit, I mean, the way that I view all of the more recent changes in programming and software development is that essentially it's yet another abstraction layer because over the past, like all history of computer and software engineering, uh, people have been creating ever more convenient ways of telling computers how to do things. And now we're at the point where you can essentially just write in natural language what you would like to have done, and then it would do it. But unlike all of the other languages that we built to tell computers how to do things, natural language is very ambiguous. There's a lot of interpretability that happens when you're constructing meaning from the way that you would write something down. And there's a lot of variability in how each person would describe something. And these errors are compounded, essentially. So now there's an additional translation error where you may tell the AI to do something, but its understanding is something different, and what it creates is a third thing that's different from your original intention. And what we're trying to do here is try and build something that can help keep your intent intact by making sure that you're either prompting the AI in ways that are going to be beneficial or are consistent with the rest of your program, as well as understanding, like, fundamentally what benefits or what areas for improvement and where they're located, so that you can give very targeted instructions to the AI model, which limits the ability for it to misinterpret you because you're being as specific as you can. And that's essentially what we're trying to do and how we fit into the ecosystem.
Amazing. Well, it was a great conversation, Avinash and Masi. Thanks a lot for joining. For folks who are watching, the links can be found in the description below. We've done some amazing things together and more things in plan. Do try out the tool. It's pretty nice, pretty handy. I've done a tutorial on it, so you can, if it's not up on YouTube right now, it'll be soon. But yeah, it was really fun talking to you, Avinash, and Masi really had a good time. And yeah, various use cases that you can find for such tools. So ideally, try it out, see what works for you, and join the community as well. So if you have any feedback, you can share that. Yeah, a lot of things in plans as Machine and Avinash have just shared. I really appreciate you both giving your time, and yeah, thanks a lot for joining. I'll see you in the next one.
Thank you so much for having us,
Yeah.
Kunal. Take care.
Likewise. I'm sure.